these three rules that we need to know for differentiating functions is called a chain rule. So we've got the product rule for when we've got two functions multiplied together, the quotient rule for when we've got two functions divided by each other. The other situation you might come across is something like this. Sine 3x squared. What we have there is two functions. We've got the 3x squared function here, but we've also got the sine function. So to actually find out what y is, to use this function, if I had a value of x, the first thing I would do is work out what 3x squared was, and then once I'd got that value, I'd find the sine of that answer. So I'm doing two operations to find y. I'm working out what 3x squared is, that's the first operation or the first function, and then once I've done that, I'm finding the sine of the answer. I've got one function inside another. And in situations like this where I have to differentiate them, then I would use this thing called the chain rule or the function of a function rule. So that second way of thinking about it is probably the most useful because it's telling you you've got one function inside another effectively. So how do I differentiate something like this? I use this chain rule which tells me that the differential of y with respect to x, which is what I'm after, equals the differential of y with respect to u multiplied by the differential of u with respect to x. That's the chain rule. As we've done with the other two, it's worth writing down this rule in Word as well, and that describes how to use it. Basically what you do is you call the inner function u. By the inner function I mean the function that you would work out first if you're trying to find the value of y. If I had to use this function to find y, as we've been saying, the first thing I would do would be to find out what 3x squared was. So we call that the inner function. And then once we've done that, we then do the outer function effectively. So the inner function, the one that you would use first to find y in this case, is called u. So we let the inner function equal u. So we let the inner function equal u. So the bit inside the brackets in this one here would be u. And then the rule tells us to differentiate the outer function, so that's the sine function in this case, with respect to u, i.e. we ignore what's inside the bracket or what we ignore what we've called u, and then we multiply this by the differential of whatever we've called u, and that's the rule. It's actually the easiest one to use once you've had a go at one or two. What makes it awkward is deciding what to call u sometimes. So for this example then, what we do is, and there's two ways to set this out. So I'll show you sort of the most precise way to set out, if you like. And then once you're confident with the rule, you can actually almost write down the answer, and I'll show you what I mean by that by doing that at the end. Okay? So what we do is we let the inner function equal u. So u is going to be 3x squared. And as before with the other rules, we differentiate that. Sticks x. And then, once we've decided, and this is what's different about this rule to the other two, once we've decided to let u equal 3x squared, we can therefore we can write y equals the sine of u, because u is 3x squared, and that's the new bit. Whatever we just ignore what's inside the bracket, in other words, and call that u. And then differentiate y with respect to u. And it's a bit of a shame that y and u are often seen together in this rule because it's easy to misread it. So make sure your y and your u are very different. The differential of y with respect to u, differential of sine, is just cosine. And now the rule tells us that the differential of y with respect to x, which is what we're after, remember, the overall differential, is the differential of y with respect to u multiplied by the differential of u with respect to x. And actually, the rule comes from the fact that if you look at this right-hand side, we could actually cancel out these du's, leaving dy by dx. And that's why it works. What we're doing is just changing the variable that we're differentiating with respect to. So, this equals dy by du, which is cos u, multiplied by du by dx, which is 6x. Now, finally, we replace u with what we set u to be, which is 3x squared. So the differential is cos 3x squared times 6x. And as before, we write the 6x first and then the cosine function afterwards. And that would be the final answer. Let's just look at the shortcut, but I don't recommend you use the shortcut until you're familiar and happy with it, okay? What you do is you look at it and you say, okay, what I'm going to do is ignore what's inside the brackets. That's like that's going to be u, remember, but so that's like the thing I'm going to differentiate with respect to first of all. So that's like my x. So it's like differentiating sine x. So the differential is going to be, the differential of sine x is cos x. But this time my x is not x, it's 3x squared. And then all I do is multiply that by the differential of what's inside the bracket, what I ignored. What's the differential of 3x squared? 6x. Answer. Okay? So that's a shortcut, but so you can almost do it in one line just by thinking about it, but only once you're happy with it. So then finally tidy up. The only difficulty with applying the function rule is deciding what u is. And this is a classic example of where you might go wrong. Sine cubed 4x. Remember, this is just a convention for writing y equals the sine of 4x cubed. That's just a shorthand way of writing the sine of 4x cubed. That's what that means, sine cubed 4x. Once you see it like this, then hopefully it's obvious what the inner function is. It's sine 4x. So my inner function is going to be sine 4x, and then once I've worked that out, I will then cube the answer to get y. So my inner function this time is sine 4x. So to do this one, I would let u equal sine 4x, so therefore the differential is 4 times the cosine of 4x, and I would rewrite the function as y equals u cubed. So the differential of y with respect to u would be 3u squared. Now the rule tells me to multiply them together. So dy by dx, if you're going to write down the rule, which is good practice, equals dy by du times du by dx. Try not to mix up the u's and the y's. So dy by dx is going to equal dy by du, which is 3u squared, pardon me, multiplied by the differential of u with respect to x, which is 4 cos 4x. Okay? And now just tidy up a bit. 3 times 4 is 12. Yeah. I'm putting that together again, effectively, yeah. So 3 times 4 is 12. U we set to be sine 4x, so it'll be sine 4x squared times the cosine of 4x. So multiplying numbers together, u is that. And remembering the convention, for that we finally write 12 times the sine squared 4x times the cosine of 4x. So a surprising answer. When we differentiate, we end up with actually a sine and a cosine in the answer.